There is it has to be like this on the tool, and there is blue to be tool, and these are right here.
Okay, what's the difference between a tool and a toy?
A toy is like a puppet. A toy is a puppet. A toy is something that
You play with.
and a tool is something that you work with.
Oh, did you hear that? I couldn't have said it better myself. A tool is something you do work with, and a toy is something you play with. So are we going to be playing with these blocks?
No.
No, sir. No, ma'am. We're going to use them as tools to solve problems, but don't touch them yet. Don't touch them yet. So you and your partners will work together. You also have a number pad on your table that you and your partner will work together with. And you're getting a dry erase marker passed out right now that you guys can write on this if you want to, or you can use your cubes, okay? To solve the problem. So a couple things I expect when we're working together, when you're working in your partners, is that you share and that you talk to each other and you work together, because y'all are all mathematicians today, and mathematicians work to solve problems together, okay? And we listen to each other. And I'm going to be coming around and asking you questions about what you're doing. And I might even say like these two, I may ask all four of you, and I may talk to four of you at the same time. So just be ready to listen when I come to your group, okay? And I'm going to take some pictures of your work. So I can't wait to see what you did. But right now, this is right. And now, oh, there it is. Okay. And I'm going to check one thing to make sure I can share to this board before we get started. Pretty sure it shouldn't be a problem. Let's try it. 1, 1, 9, 4, 9. I think we're good. Yep, there I am. Okay, good. So let's go back. Thank you for being so patient while we work. And then let's see, I have to do presentation, right? How do I make this go? Well, maybe just, he does not want to cooperate with me. Okay, that'll work. Okay, we'll just do it that way. All right, I think we're all ready. Thank you for being patient. Are y'all ready? Is everybody here? We're all good to go. Okay, great. All right, we're going to get started with our math lesson for the day. Are you guys ready?
Yeah.
Awesome. Okay, so here is what we are learning today. I hear you guys have been working to solve some addition subtraction problems. And so today you are learning to solve problems on a number pad. So you're going to be solving problems. This is your number pad. See this? You're going to use this to show me how to solve the problems. But you also can use your math tools as well to show it. Okay, so you can write on this with your dry erase marker, or you can model with these, or you can kind of do both. But to be successful today, you are going to have to model the problem. So modeling the problem means using these cubes, using this pad. If you haven't done that, are you successful today?
No.
Nope. So you got to use the cubes in the pad. So that's part of our success criteria. And you also have to write an equation. You guys been writing equations for the past little bit?
No.
So you're going to work to write an equation that shows how to solve the problem. Are you ready?
Yes.
You ready for our problem?
Yeah.
Okay. How many people have bicycles?
2.
Oh, you have a bunch of bicycles? You have 2 bicycles? Or you're saying you see 2 up there? Do you all have bicycles?
Yeah.
Do you like to ride bicycles?
Yeah.
Oh, me too. Well, I have a friend, and they are working on getting some new bikes to share, and they had 7 bikes. 7. That's a lot, isn't it? 4 of their bikes are red, and the rest are black. We've got to figure out today, guys, how many are black. And so I want you to think about how you can find out. And don't forget, you have to use your number pad and write an equation to show how many are black. Do you think you can do it?
Yes.
All right, so I'm going to set my timer, and I want you and your partner or partners to get your tools out. And I want you to figure out if there are 7 and 4 are red, How are you gonna find out how many are black? So you guys are working on that. My timer starts now. You can begin. Yeah. All right. Let's start over here. Tell me what you know about this. What do you know? There's 7 bites. Can you use, remember part of our success criteria is to model. So can you show me those 7 bites?
Only have 4.
Remember, we're working together, so y'all gonna work together to make 7? So how many do you have? 3.
I'll get it.
Gonna help her finish making 7? She has 3.
Okay, let's put this on the left.
Okay, can you put them all together to show the 7? So we know there's 7. How many are red? How many are red according to our problem? 4 are red. So how are you guys gonna figure out how many are black? What would you do?
I'll get more. I'll get red. The rest are
Yeah, you would do what?
take.
Okay, you're gonna take 4 off of that. So could you do that? Can you guys show me that with your model? And I want to come back and see what that looks like, okay? So put your 7 together, put them up here, work with your partner. So you have your total 7, and I want you to show me if you're gonna take 4 off, how many are black? And then remember, part of our success criteria is writing an equation. So what will that look like? Okay, I'll be back. Oh, tell me about your model. What's happening here? Let's all talk. Let's 4 of us talk. What are you guys thinking here? How many? You're jumping. What are you gonna start with? She's gonna jump. Have you guys been jumping on your number pad yet? Not yet. Well, let's see what she's thinking. So let's all listen to our partner, okay? So she says she's starting at 7, you said? What did you say you're starting with? 7, and then what does 7 represent on our problem? There's 7 bites and 4 are what? Red. So she's starting at 7. What do you think she's gonna do next? Oh, she's gonna count back to 4. And then what? Go ahead and show us how to do that. Can you show us that? So starts at 7. So she counted back 4. I'm gonna take a picture of that. Hey guys, I want y'all to think about this. So she started at 7 and she counted back 4. You see that? Lines of the glare. Oh, so if she went back 4. So how many bites are black? 3. So when you go backwards on a line, what are you doing? Taking away. What operation is take away? Subtraction, right? What you said? So can you remember part of our success criteria is to write an equation. So you just went back and our friend here said that was to take away. So I want you to work together and think about what the equation would look like to show the 7 and you took away. Oh, perfect. Remember, you guys work on your model too. Our success criteria is not just to model, it's to write an equation. So I want you to think about what the model looks like for this equation. And is there another equation? All right, guys, what you thinking over here? Okay, you started at 7 and you stopped at 4. Why did you do that? Okay, where does it say take away 3?
Wait, it didn't say take away 1.
You're doing 7 because what's the 4 represent on our problem? The 4 was what? No, but 4 are how many are what? Red. Do you remember that? So she did 7 are total, our whole. And our part is 4, right? So how many are black then? How did you figure out how many are black?
1 to 3. I did 1 to 3 and 1 to 4. Mostly going to 4.
So you said this is 4, that's how many are red, and this is 7, our whole, right? And how many total bites. So could you go up? Could you show me how to go from 4 to 7? How many steps is it from 4 to 7? You start at 4. 1. Oh, almost. And she's writing an equation. So in our equation, go ahead and finish yours. But in your equation, what is your whole? 7. And what are we doing with that 4? Can you do the little arrow right there? Because you went backwards. And you're doing this one this way? Okay, so I'm taking another picture. Okay, so you started with 7. And so how many are black? How many? So you have, oh, your black colors here. How many bikes are black? So you had 7 bikes and 4 were red. How many bikes were black? How many steps did you count backwards? So you went 7 and you went backwards. How many steps? 1, 2, 3. So how many are black? So if our whole is 7 and our parts are 4 and 3, I want y'all to put an equation that shows the parts that make the whole, okay? Did you guys get my model that works for this? Did you get me a model? So this one is
Must be 3.
7, and what is it? 4. And so can you tell me where is it? This is the 7. This is the 7 bikes that they have. And 4 are how much? Or what color? Are red. And so how many are black? 3. So can you show that here on your model? Where are the 3? So if you started with your whole of 7 and you said there 4 are black, red, and the rest are black. On this one, let's look at your equation. You started with 4. So when we're writing subtraction, what do we start with? Our part or our whole? Oh, keep going, keep going. Start with your whole. Yeah. So did you start with your whole here? No, but keep going right here. Keep writing that. You said 4 plus 3 equals 7. Could you underline that 3 for me? Just put a line under it. So when you're thinking about how you solve this problem and you put plus 3, you see your model? How did you show plus 3 in your model? How does your model show adding 3? I want y'all to talk to your friend. Why does he have adding? You guys have subtracting. Is he right? Convince him that you're right, but he's not. All right, let's talk to you two groups here. Talk to me about your model. What are you thinking here? I noticed that our friends here, look what they're writing. 7 minus 4 equals 3. Why do you think they wrote 7? Why do you think they wrote 7 first?
I don't know.
Huh? You don't know? How many bikes were there altogether? Well, let's read the question. There are 7 bikes. How many bikes are there altogether? 7. And how many are red? 4. And so why did they take the 7 off? So how many, which one of these shows how many are black? So 3 are black. Is that what you're showing me? Yeah. So remember, part of our success criteria is to model. Yes, you did. Can you tell me about your model? What are you making here? And your model, you guys can use the blocks to show that same model. Show the blocks. Tell me about your model. What does this show? Oh, you're trying to make 7 plus 4. Okay. Oh, we have about a minute and a half or 2 more minutes. Remember our success criteria: model and write an equation. Are you there? I'm coming to check. If you've modeled one way, can you model another? So you have your 7 plus 4. You're going to do 4 plus 3. Can you show in your equation what that looks like, and how does that in your model? Where was your 4? Where's your 7? Where's your 3? Yeah. So where are your parts? Can you show your parts? Yeah. Okay. So you had 7, and you had 4 that you had that you knew were red. So what are you going to do with those 4 you knew were red? Okay. So you're going to pull those 4 off like that. How many are left? 3. So if you were thinking about these are your parts, how could you show that in an addition equation? Why would you say that that was addition? She wrote subtraction. I want y'all to talk about which equation should you write, an addition or subtraction? All right, talk to me, guys. What do you think back here?
So, we thought about 1, 2, 3, and like a line. So, and then there's 3 more numbers.
Okay.
So, 4 plus 3.
I'm following you. So why did you stop at 4? What does that 4 represent?
So, if you got only 4 here.
Yeah. So in our problem, 4 were what? Yeah. Do that. I love that. That's awesome.
And then 5, 6, 7.
Yeah. So how many were black? You can leave that there. Go ahead and leave that right there. I want to take a picture of that without it. So how many were black then? You said 5, 6, 7. So how many were black?
3.
3. Why is he saying 3, y'all? I'm confused. Why is he saying 3? Because it says right here 7. Why is he saying it's 3 were black? 4 plus 3 equals 7, which is what you wrote in your paper, right? So what I'm wondering is, what were your parts and what were your wholes? So your parts were what in 4 plus 3 equals 7?
Well, there was another way.
Oh, there's another way?
Yeah.
What do you do?
4 plus 3.
You put them together. I love that. What I'm wondering, is there another equation you could write? Remember, you know the parts and the wholes. The parts are 4 and 3, and your whole is 7, you said. So is there another equation that could show that 4 as the answer, or 3 as the answer? Y'all talk about that other equation. I'll be right back. Oh my goodness, look at all of these. Tell me about why you have all of these written. You don't know? What does the 7 represent? The total or the whole, right? And the 4 and the 3 are the what? Someone take a picture of that. A very good picture of that. So the 4 and the 3 are the parts. So why are you adding some and subtracting some? Not sure? You just wrote your fact family that you know about? But let's think about our problem. What do we know? We knew there were 7 bikes, and how many were red? 4. And so how many are black? 3. So, but if I knew there were 4 bikes, what can I do on my number path to figure out how many were black? So if I'm on my number path and I'm at 4 bikes, can you show me where 4 is? How many total bikes are there? Put your finger on that. So keep your finger here. Listen here, listen here. How far is it from 4 to 7? If you were hopping on this line. Oh, and when you hop forward on the line, are you adding or subtracting? Adding. So which equation does that represent? I want y'all to talk about that before. That's good. All right, let's come back together. Excellent job, mathematicians. Here's what we're going to do. We are going to share some solutions. Now, Tommy, take some pictures. So here's what I need you to do. Tools back in the cups. So go ahead and put your blocks back in the cups. And we're going to look up here at the board at some of our friends' solutions. Right. So during this time, we're not playing with our blocks anymore or using them as tools to do work like our friend said up here that we're using them.
No, you don't put it there.
We are going to look at some solutions and talk about what, you guys did an excellent job today. Remember, part of what we were learning today to solve those problems using a number path. Were you able to use your number path today? Yeah, and you were modeling with blocks. And did you write equations?
Yeah.
I saw a bunch of equations. So were you successful today in meeting that criteria? Yeah, so let's take a look at some of our models. Oops, wrong class. Here it is. The one I want to start with. Okay, so I want us to spin it. Let me spin it for you so you can see. All right, so I want us to look at this model. See that? Yeah. Okay, so here's what I want you to think about. See this block? Yeah. See these blocks? Yeah. Why did they make this many blue? How many blue are there? You and your partner are going to talk about it. How many blue do you see and how many red do you see? What does this represent in our problem? Remember, there were 7 bikes and 4 were red, and we were trying to figure out how many were black. Remember that problem? Turn and tell your neighbor, what does this show? What does this show? And what does this show? Turn and tell your neighbor. Turn and talk to your neighbor. Turn and talk to your neighbor.
I think you can do nothing
Let's come back together. So what did you and your partner talk about? What? How many are here? 7. So you have 7 here, right? Yeah. So you're saying that this is 7 here. And what does that 7 represent? The 7 bikes. Remember, there were 7 bikes. So I want you to turn and tell your neighbor. Well, hang on just a minute. We'll come back and tell our neighbor something else. What are these? How many are here? 4. And what does that 4 represent?
The 4 red bytes.
The 4 red bytes. So what were we trying to find out? How many were black, right? So I want you to turn and talk to your neighbor. So what is your part and what is your whole? If you're looking at this, what was your whole? What was your part? And how are you going to figure out the other part? Turn and tell your neighbor. What was your whole? What was your part? How are you going to figure out the other part?
What was we know that 7
You went to 11, yeah. So let's take a look. Everybody up here, what was our whole? What did you and your partner say? What's the whole? 7. Uh-oh. There we go. 7. I didn't even do that. Made it bigger, didn't it? So our whole was 7. And so what was our part? 4. And so what are we missing? Oh, we're missing the other part, aren't we? Missing this part right here. Wonder what that is. They're saying 3. So if 4 and 3, do they make 7? We have our part wholes. Interesting. So you modeled with the blocks, and you're telling me that the 7 was the whole, the number of bytes. 4 was the part that were red, and the 3 was the part that were what color?
Black.
Okay, so I'm wondering, now remember, part of our success criteria was to model, but to use a number path, right? So let's look at a solution on a number path, and let's talk about how they're modeling on a number path. Hang on, let's you know which, hang on, let's trying to find it. Okay, here we go. So we're gonna look at 2 different number paths. So let's look at this one right quick. Maybe I'll spin it like this and then make it really big. Okay, and oh, so much bigger. Remind myself. Hold it. Okay, so here we are. Y'all see, remember, we've already said our whole was what? 7, and our part was what? 4, and our other part was what? 3. So on our number path, though, what's happening here? I want you to turn and tell your neighbor, what did they do to solve the problem? And where are the parts in the whole? The 7, the 4, and the 3. Turn and tell your neighbor what they do to solve the problem. And where are the parts in the whole?
I don't know how to solve
What they do to solve the problem. So they're going back. So when you go back, what operation? You go back, and you add and subtract. So they're subtracting. Maybe they subtract. So there, how many jumps did they do? Subtract. 4, 2, they subtracted 4. And so their answer they landed on was. Well, they started at 3, they went up, and they going backwards. You landed 3. Okay, let's come back together. So we talked about parts and wholes already. So here's what I'm wondering. What did they do to solve the problem? What did you and your partner talk about? Where did they start? Where did they go? What do you think they did? You want to share with me what you think they did? What did you and your partner say they did? They started at what? 7. You think they started at 7, and then what did they do? You said they went backwards, right? 1, 2, 3, 4 steps, right? So they went backwards 4. Where did they land? 3. Do we see our parts and wholes from the last problem? Do you see your whole? 7, and they did their part 4, and they landed at their other part 3. What did they do? When you go backwards, what operation are you doing on the line? Minus, right? Subtraction, right? So they're going backwards on the line. Could they have gone the other way? No, they couldn't go it from 3 to 4. I mean 3 to 7. We're gonna look at a couple of solutions in just a second. So you're telling me we started with the whole, we took off the part we knew, and what did we land on? 3, the part that was missing. Remember, the 3 is how many bytes? What color were the bytes? Black, right? So we knew this was the red, so we started with our whole, we took off a part, we landed on the part. So let's look at this number line, because it is different. They didn't start in the same spot. So let's spin it. So remember our last one, they started at 7 and they ended at 3? What's different here? I want you to turn and tell your neighbor what's different, and did they get the right answer? What did they do? Turn and tell your neighbor what's different, and did they get the right answer? But they started the whole and they went to the what number did they go to? So that part, where's the missing part? How far is it from 7 to go back 3? How many steps? All right, let's come back together. So what was different than this line and this line? So this line we just looked at, and this line we're currently looking at. What's different?
They
didn't stop at 3. What did they stop at? 4. But did they start at our hole?
Yes.
Yeah, so they have our hole of 7 here. Hard to see, it's scribbled out, but 7. And what was the 4 representing? It was what? The part that was red, right? And so where's the part that was black? How did they find their answer? Where's the part that was black? Y'all see it? 7 was the total, 4 was red. The missing part is what? We already know the answer. The missing part is what? 3. Where do you see 3? Where's the 3? Oh, it is right there beside the 4. But where do you see the 3 in our between here and here? Do you see it? So we go 1. Remember these jumps? 2, 3. Look at that. How many jumps is it from 7 to 4? 3. So do we still have our part and our parts that make our whole? So wait a minute, y'all. You're telling me that I could start at 7 and I could jump back 4. Jump back 3 to the 4. Or I could start at 7, whoops, and I could jump back the 4 and land at 3. Did it matter which one we started at? It did matter which one we started. Did it matter which one we ended at? No, our parts are just in a different spot. This one's in 3. The other one had the part. The part was here. The 3 was right there. Interesting. So we talked about the number path and how we could jump. But what about that equation of our success criteria? So I want to show you an equation here. First, I want to show you this one. And then I will show you the equation that goes with it. Okay? So this was another number path model. Okay, so look at this one. So do you see that? They had 4, and then they had 5, 6, 7. So do we say our parts and our wholes? I want you to think about what this equation, this is the equation they wrote for this one. Are you ready? And you see that?
Yeah.
That's the equation. Wait a minute. I thought y'all were telling me we were removing 7. We were subtracting. Is that not what you're telling me? Or removing from 7? Were we not subtracting?
No.
Did we not subtract on the last 2 number paths? We did, didn't we? We went back. But wait, our friend in the back says we can do what? You could do both. Wait, I'm confused. I'm going to need you to turn and talk. So they're saying that they had here and they added 3. So you see that 4 and I added 3. Why are they doing that? Why are they adding 3 on a subtraction problem? Turn and tell your neighbor, why are they doing that? Why can you do both? You're saying you can do both. Was this y'all's model? Is this your model? That was yours. But was this your question? I don't think that's your question. So why do we have the 3 underlined there? Yeah, so do we still have our whole of 7? So instead of starting at the hole and taking them off, what did they start with? What did y'all start with? The parts, right? And then you went to the hole. So either way, you're finding a distance or difference between the 2. Okay, let's come back together. So if you remember, let's remember all of our solutions we've seen so far. All of the other 2, we started at 7 and we removed 3. Or we started at 7 and we removed 4. Do you remember that? And our friend said that's subtraction. When you remove, it's subtraction. So these guys, what did they start with? The part or the whole? They started with the part, and where did they go? To the whole. So where is the missing part? If this is our 4, right? And what's our whole again? 7. So here's our 7, right? Where's the missing part? 3. So they counted up from the part to the whole, and they found their missing part of 3. Wow. Did you know that you could do that?
We can't.
So yeah, we knew that. So some of us removed the 3. Some of us removed the 4. Did we get the right answer? Yeah, we still knew that there were 3 black dots. This group said, you know what we're going to do? We're going to say 4 plus what equals 7. So they said 4, 5, 6, 7. So they counted up. Turn and tell your neighbor, what did they do to solve this problem? They did what?
They counted up.
Oh, I hear them again. Can you say it loud for us? What did they do to solve this problem? They counted up from the what? Part to the whole, which gave us that missing part. Wow, that is an interesting strategy. I wonder if that works every time. What do you think? Yeah, so I had some people who wrote this equation because they were doing, I should have shown this one first. Hang on, spin it again. So this equation shows our part being removed, right? Our 7, and we took 4 away and we got 3. But we also can think about it as 4 plus what? We can count up to our part to solve the problem. You guys did an excellent job solving your problems today and modeling with your blocks and with your number path. And I think you discovered a new strategy you could use to solve a subtraction problem. Do you always have to remove to find the answer?
No.
No, because that group, they started at the what? The part, and they counted up to the whole to find the missing part. So that's a different strategy that you can use to solve the problems. You did an excellent job at modeling that today. So we have an exit ticket, I think, for you. So you guys were able to meet both of your success criteria today. I'm so proud of you. And so I think it's on page 132, page 3, 4, and 5. Do you have those books that we can get those out? So we're going to do a couple problems from your book, and it's going to be, guess what, a number path. And you're going to be solving problems on the number path like you were today. And I want you to think about your strategies that you use where you could remove, but you also could count up to solve the problem. You guys did a great job today. Thank you for letting me come in your math class. I'm going to come by and pick up the tools from your group while we get your, are there books like near them that they